Today we're going to be looking at current and voltage in series and parallel circuits. So firstly we're going to look at series circuits. I'm going to build this circuit and then we're going to measure the current at position 1, 2, 3 and 4. So we're going to measure the current at these points in the circuit. So I've set up the circuit as shown in this diagram, but instead of using a battery, I'm going to use a power pack just to make it a bit easier. So this is the circuit. We have 3 bulbs. They're all on, and it's a series circuit because it only has one loop, which means the current only has one pathway. So we're going to start by measuring the current at position 1 right there. So I'm going to break the circuit. And I'm going to put an ammeter into the circuit. This is what we use to measure the current. Okay, the light bulbs are back on. And as you can see at position 1, the current is 0.12 amps. So we're going to write that into the table. Position 1, 0.12 amps. So I've put the circuit back together and now we're going to measure the current at position 2, which is between the first 2 bulbs. So we're going to break the circuit here and we're going to insert the ammeter into the circuit. And as you can see, the current between the first 2 bulbs at position 2 is also 0.12 amps. Don't worry about the negative sign. It just means, it just shows the direction of the current. So it's 0.12 amps again. Now we're going to do the same thing at position 3, which is between the next 2 bulbs. Once again, I'm going to break the circuit between the next 2 bulbs and insert the ammeter into the circuit. And as you can see, the current once again is 0.12 amps. Now we're going to do the same thing at position 4, which is between the battery or power pack and the last bulb. So I'm going to break the circuit and I'm going to insert the ammeter. And as you can see, once again, the current is 0.12 amps. So what does this mean? This means that at all points around a series circuit, the current is the same. Because it only has one pathway to flow around the circuit, the current is the same at all points in the circuit. Now we're going to take a look at the voltage in a series circuit. So it's the same series circuit, but instead of measuring the current, we're going to use a voltmeter to measure the voltage at position 1 over the power supply, position 2, 3, and 4. So we'll be measuring the voltage. So we'll need a voltmeter, and we connect the voltmeter in parallel. So we don't break the circuit when we connect the voltmeter. So there are 2 extra holes in the wires here, so I can measure the voltage of the power supply by connecting it here. And as you can see, the voltage over the power supply, once again, ignore the negative sign. If I switch these around, it becomes positive. So you'll see it's 11.7. So position 1, the voltage is 11.7. Now we're going to measure it at position 2 over the first bulb on this side. So at position 2, I'll connect it in parallel again. Over first bulb, you can see that the voltage is 3.7, we'll take 6, 3.76. Now we're going to measure the voltage at position 3, which is this bulb in the middle. So once again, I'm going to insert the voltmeter in parallel, so it has its own loop. And you can see that the voltage is, we'll take 3.74. And finally, we're going to measure the voltage over the last bulb at position 4. And we'll take the voltage as 3.7. So what does this mean regarding the voltage in a series circuit? Well, if we add up the voltages at position 2, 3, and 4, we get 11.20. So it's not exactly the same as the voltage over our power supply, but it's pretty close. So as you can see, the voltage from the power supply is shared between the components in a series circuit. So the voltage in a series circuit is shared, unlike the current, which is the same.